Okay, hello everybody. Let's look at section 5.3 here. So we've talked about the unit circle and we've talked about the two main trig functions, which are sine and cosine. So this section is about other trig functions that exist. There are a number of them. So first off, you have tangent. And so again, if cosine is equal to x and sine is equal to y, let's jot that down here. So cosine of t is equal to the value of x, sine of t is equal to the value of y for the points on the unit circle. So then these definitions in terms of y and x would be for the other trig functions that exist. The first is tangent, which is going to be x over, or is going to be y over x. Cotangent is just the reciprocal. It's x over y. So you have tangent, which is y over x. Fun fact, another common definition of tangent is that it is the sine divided by the cosine. I think we'll be introduced to that formally later, but sine divided by cosine. So in other words, y divided by x, that is the definition of tangent. You also have the reciprocal functions, one of which is cotangent, which is the reciprocal of tangent. And then this kind of trips up students a lot here, but just so that you know, so they have secant, which is what SEC is short for. Secant is a trig function. Here they define it as 1 over x. Secant is actually 1 over cosine of t. So it is the reciprocal of cosine. Meanwhile, so this one is secant. Meanwhile, there's the cosecant, and the cosecant is abbreviated CSC, and the cosecant of t is equivalent to 1 over sine of t. So cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. It's kind of backwards from what you might expect. You might expect cosecant. You might expect cosecant would go with cosine, but it's actually the opposite of that. The way I always remember it is that if you write out the different trig functions here, the trig functions and their reciprocals. So you have sine of t corresponding with cosecant of t. You have cosine of t, which corresponds with secant of t. And then finally, you have tangent of t, which corresponds with the cotangent of t. And the way I always remember it, each pair has only one cofunction. So each pair has only one cofunction. So the cosine goes with secant, the cosecant goes with sine, and then the cotangent goes with tangent. So that's the thing I always use to help me remember which trig function reciprocal goes with which. So anyway, we now have 4 additional trig functions at our disposal here. So here they say the point negative root 3 over 2 1/2 is on the unit circle. They say find the sine of t, the cosine of t, the tangent of t, the secant of t, the cosecant of t, and the cotangent of t. So just to reiterate, X and Y are the coordinates of that point. The X value is the cosine, the Y value is the sine. So if we're going to do this, we know that cosine of t is going to be negative root 3 over 2. We know that the sine of t is going to equal 1/2. Those are the easy ones. Next, we need to find tangent. So to find tangent of t, that's equivalent to sine over cosine. That's the definition of tangent. So the value we have for sine is 1/2, and I'm going to write it this way. The value we have for cosine is negative root 3 over 2. Our goal is to simplify that statement. Now, you might remember this from back in the day. If you're going to divide fractions, you want to multiply the reciprocal. So essentially what that means is if I have 1/2 divided by negative root 3 over 2, what I'm going to do is switch that around and call it 1/2 times a negative 2 over root 3. So we flip the fraction upside down and then we multiply instead. Now what happens is the 2 and the 2 will actually cancel each other out. So what we would be left with is just negative 1 over root 3. It is kind of frowned upon to have a square root in your denominator. So what we will then do is we will rationalize the denominator here by multiplying root 3 on top and on bottom. And when we do that, when all is said and done, you end up with negative root 3 over 3. So all of that is what tangent is equal to. So tangent of t is equivalent to negative root 3 over 3. So then after that, we have the cosecant of t. That's 1 over sine of t. It's the reciprocal of sine, which means we do 1 over 1/2. That's going to basically flip the fraction upside down and make it 2 over 1, also known as 2. So then the cosecant of t is just equal to the number 2. Meanwhile, the secant of t is going to be the reciprocal of cosine. It is 1 over cosine of t, which means we're going to do 1 over negative root 3 over 2. We're going to flip that fraction over. So that's going to flip over to be negative 2 over root 3. We're going to rationalize the denominator here, multiply top and bottom by root 3. And that'll give you negative 2 root 3 over 3. So that's what the secant of t is equal to. I'm running out of space here. Secant of t is going to be negative 2 root 3 over 3. There's where the secant is. And we've got one left, which is the cotangent. And here's what I'm going to do. I'm going to go back here to the tangent. This is what I obtained earlier, and it is equivalent to the tangent of what I'm looking for. And the thing to remember is that the cotangent is just the reciprocal of tangent. So cotangent of t is equivalent to 1 over tangent t. It is the reciprocal of that. So what I'm going to do is I'm going to do 1 over a negative 1 over root 3. I'm going to do the reciprocal of that. Fun fact, that is just going to equal negative root 3. You flip it over, you have a 1 on the bottom. Dividing by 1 doesn't do much. So when all is said and done, you end up with this, which is cotangent of t is equivalent to negative root 3. And then all of that all of that are the solutions. Those are all 6 trig functions that we have for that particular point on the unit circle. All right, here's another one. So they ask us to find the values for sine, cosine, tangent, secant, cosecant, and cotangent. All right, so again, sine and cosine are the most straightforward ones. Cosine is the x value, which in this case is √2/2. Sine is the y value, which in this case is -√2/2. If we're going to do tangent of t, fun fact, that is sine over cosine, which means it's -√2/2 divided by √2/2. Well, fun fact, it does not matter how complicated it is. If you take something and divide it by itself, do you know what you get? You get 1. So there you go. Or in this, well, there's a negative there. -1 is what that is. So tangent of t is going to be equivalent to -1 in this case. So when the sine and cosine happen to be equal numbers, you end up with a 1, or in this case, a -1. Now, what are we going to have for cosecant of t? That will be the reciprocal of sine, which means we're going to do -2/√2. If we were to, so if we flip it over, we get that. Then what we're going to do is we're going to rationalize the denominator here. We're going to multiply top and bottom by √2. When you do that, you would have -2√2 all over 2, because √2 times √2 is the number 2. And then check this out. You got 2 divided by 2, which will cancel out. So in fact, what you end up with for cosecant is just going to be -√2. Okay, so there is that one. Then what we need to find is secant of t. That's just going to take cosine and flip it over. So I'll just note here, this is 1/sine for cosecant. And then I'll note this is 1/cosine for secant. So if you flip that one over, it's going to be 2/√2. And then something very similar to what we did last time is going to happen. You're going to multiply a √2 on top and on bottom. When you do that, you will end up with 2√2/2. And then just like before, the 2's will cancel each other out. So when all is left, when all the chips have fallen, secant of t is going to be equivalent to the square root of 2. Finally, we have cotangent of t, which is just the reciprocal of tangent of t. And then just to reiterate here, tangent was the sine of t over the cosine of t, just to reiterate that. But anyway, so if you're going to do cotangent of t, if you're going to do the reciprocal of tangent, you're still going to end up with -1, because you're going to, if you flip this thing over, you get √2/2 divided by -√2/2. But guess what, my friends? The reciprocal of a number of 1 or -1, the reciprocal is exactly the same. So it's still -1. That'll be what we have for the cotangent. So when all is said and done, there are the 6 trig values for that particular point on the unit circle. Okay, let's see. What else do we have going on here? So they say find sine t, cosine t, tangent t, secant t, cosecant t, and cotangent of t when t is equal to pi/6. So here we're going to kind of combine what we were just doing together with the unit circle stuff that we were talking about last class. I think it's always a good idea to draw a sketch to help visualize what we're talking about here. So pi over 6 would be this angle right here in the first quadrant. That is equivalent to 30 degrees because pi is 180. 180 divided by 6 is 30. Across from 30 is where you have 1/2. The adjacent side, the other side, is going to end up being √3/2. So if we're going to figure these out here, well, just like before, sine of t is going to be the y value, which is 1/2. The cosine of t is going to be the x value, which is √3/2. Then we need to find the tangent. So I'm going to show you all a little shortcut here if you're going to evaluate the tangent. So you need to do the sine over the cosine. So you're going to do 1/2 over √3/2. Now, originally what I did was I went back to the definition. I said, okay, I've got a fraction divided by a fraction. So I need to multiply the reciprocal and then cancel some stuff out. Well, to save ourselves a bit of time and effort, I'm going to show you a little trick here. Because fun fact, what you might notice is that this is a fraction over 2, and this is also a fraction over 2. So you can, in fact, just cancel those out directly because you're dividing the same thing from both sides of the equation, from both sides of the fraction. So you can, in fact, use a little shortcut here and just cut to the chase and end up with 1/√3. You're still going to rationalize here. You're going to multiply by √3 on top and on bottom. And when you do that, you end up with tangent t. That's going to end up giving you √3/3. I will also go ahead and just say right now that cotangent of t, if you go back to this definition, which is 1/√3, you can find cotangent of t by just doing the reciprocal of this, which is √3/1. And fun fact, any fraction over 1, you just kind of ignore the 1. Dividing by 1 never really does anything, so we just kind of leave it off and simplify it. And so cotangent of t in this case is going to be √3. Now all we need to do is find the cosecant of t. We need to do the reciprocal of sine, which is 2/1, also known as just the number 2. And then finally, we need to find the secant of t, which is the reciprocal of cosine, 2/√3. And then like we did before, we're going to rationalize this. And when you do, you end up with secant of t. That's going to be 2√3/3. So those are the 6 trig values for the angle of pi over 6 radians. So that's all. The 2 basic values, sine and cosine, come from the unit circle values that we were talking about last time.
Sir, cosecant the √3/3. Cotangent. It shouldn't be √3/1. It should be over 3, right?
For the cotangent?
Yeah, √3/1. Why? √3 is 3.
Yeah, so the cotangent should just simplify to be √3. If you use this version, if you have if you flip it over and make it 3/√3, if you rationalize it this way, you will end up with 3√3/3, and then the 3's will divide down and reduce, and it will leave you with just the square root of 3 for the cotangent.
Not bad.
Does that make sense?
Yes, sir.
Okay. What I personally like to do is kind of go back to this version and just do the reciprocal of that. But if you go back to the definition, if this is your value for tangent, if you rationalize it this way, you're going to end up with a 3 that you're going to cancel out. So however you do it, it will end up giving you the square root of 3. Let's see. So those are the 6 trig values for that particular angle, pi over 6. This is very similar. This time we're going to be doing it for pi over 3. We'll be getting a lot of the same values. We're just going to kind of have them rearranged, quite honestly. This is pi over 3, which is equivalent to a 60-degree angle. Across from 60 degrees is where you're going to have root 3 over 2. The corresponding side will be 1/2. So then what we know from the get-go, the sine of t, that's going to be the side that's the y direction. That's going to be root 3 over 2. The cosine of t, that is going to be 1/2. For the tangent, if you're going to do tangent of t, that's going to be root 3 over 2 divided by 1/2. And then you can cancel out the over 2 parts. So tangent t in this case is going to be equal to just the square root of 3 in this situation. Meanwhile, if you're going to do the cosecant of t, you're going to do the reciprocal of sine. This is 1 over sine of t. So that's going to be 2 over square root of 3, and we need to rationalize our denominator right here, 2 root 3 over 3. So we have the value of cosecant, 2 root 3 over 3. For secant, that is the reciprocal of sine, or I'm sorry, cosine is secant is the reciprocal of cosine. So if you do the reciprocal of cosine, that's 2 over 1, which simplifies to just give you just 2. So secant of t is going to equal 2. And then finally, for the cotangent of t, we know tangent, which is root 3. So this is going to be 1 over tangent. So this is going to be 1 over the square root of 3. We're going to rationalize here. And that gives you root 3 over 3. And that'll be the value we get for cotangent. So that's all of those. Try to do this without trying. Oh my gosh. Okay, there we go. So there are all 6 trig values for pi over 3. And a lot of those are very similar to what we got last time. They're just kind of rearranged in a different order. There's only so many variations you can have of these values, but that's what we get for pi over 3. Here is a table that's kind of showing us some of these different values here. One thing I want to draw your attention to are some of the values for 0 radians. So if you are doing, for instance, cosine of 0, so if we're at 0 right here, there's our unit circle. It has a radius of 1. And so this point is the point 1, 0. So then the cosine of 0 is equal to the number 1. The sine of 0 is equal to the number 0, which is the y value at that point. If you were to do tangent of 0, that's sine divided by cosine, so that's 0 over 1. Fun fact, 0 divided by 1 is just the number 0. It is possible to take 0 and divide it by other numbers. You cannot, however, divide by 0, which is going to come into play when we try to do some of these reciprocal functions. If you're going to work out the secant of 0, that's the reciprocal of cosine, 1 over 1. which fun fact is still 1. If you're going to try to do the cosecant of 0, that's going to be 1 over 0 because you're doing the reciprocal of sine, and that is undefined because it is not possible to divide by 0. Meanwhile, if you try to do the cotangent of 0, the same thing is going to happen. You're also going to get 1 over 0, which is also undefined. So you will notice in this table that they provide you, they have values for 0 radians. And because that is defined as 0 for sine and tangent, the reciprocals of sine and tangent are going to be undefined values. In a similar fashion, I'm not going to go through all the details with this one, but a similar thing happens when you do pi over 2, also known as a 90-degree angle. So here you can see there's the point. Again, the radius is 1, and this is going to give you the point 0, 1. And so again, this time because the cosine is 0, the values that have a cosine in the denominator, secant and tangent, those end up giving you undefined values. This is just reiterating what function is positive in what quadrant. So we talked last time, I told you the little mnemonic, all students take calculus. And so for the 3 basic functions, all of the 3 basic ones are positive in quadrant 1. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Here, we're just expanding our perspective a little bit. And the thing to know is that you mainly want to focus on the 3 main trig functions, which are sine, cosine, and tangent. And then the thing to remember just in the back of your mind is that the reciprocal function will also be positive in that particular quadrant. So if you're in the quadrant where tangent's positive, that implies its reciprocal cotangent is also positive by extension. Fun fact, doing the reciprocal of something doesn't ever alter its sign. It just flips the fraction upside down, but the sign remains the same. So this is just pretty much what we talked about last time. We're just adding in the reciprocal functions here for each of the 4 quadrants. So given an angle that's not in the first quadrant, you can use reference angles to find all 6 trig functions. And again, we were doing some of this last time, but basically, if you know the reference angle, you can find the basic trig values that you want. They're usually going to be root 3 over 2, root 2 over 2 and a half. And then depending on which quadrant you're in, you can then determine whether it is supposed to be positive or negative based on if you're in negative y territory or if you're in negative x territory. So here they say use reference angles to find all 6 trig functions of negative 5 pi over 6. So where, pray tell, would negative 5 pi over 6 be? Well, the first thing to note, it is a negative angle, which means it is going to spin clockwise. This is negative 5 pi over 6 right here. This is pi, also known as 6 pi over 6. And really the nice thing about radians is that if the denominator is 6, your reference angle is just going to be 6. This is going to be pi over 6 for our reference angle. And again, because of how I learned geometry, I find it helpful to always think of it in terms of 30 and 60 or 45. The one across from 30 is a half. The one across, the other corresponding side is √3/2. And then fun fact, we are down, which means we are in negative y territory. And we are left, which means we are in negative x territory. So both of the sine and cosine values are going to be negative values. So based off of this, they want us to find the 6 trig functions. So sine of t, we'll just call this t here. So sine of t, that's going to be -1/2. The cosine of t is going to be -√3/2. The tangent of t, we saw this earlier. If you do -1/2 divided by -√3/2, you can cancel out the over 2's. A negative and a negative is going to switch to positive. And if you have 1/√3, you can rationalize that and get the result, which is √3/3. If you do the reciprocals, cosecant of t will be -2/1, also known as -2. If you do the reciprocal of -2/√3, we will see this value again, which is -2√3/3. That'll be the reciprocal for cosine. -2√3/3. And then finally, for the cotangent, we saw this earlier, but if you do 3/√3 and multiply that, you'll have 3√3/3. You can reduce the 3's right there. And when you do, you end up with just the square root of 3. And those are the 6 trig values for that angle. And one thing I just want to note, this, by the way, is a good indicator of why tangent is positive in the third quadrant, because tangent is sine divided by cosine. Fun fact, if they're both negative, we know a negative divided by a negative gives us a positive answer. So that's why tangent is positive in the third quadrant. Okay, let's see what else we have going on. They say use reference angles to find all 6 trig functions of -7π/4. Okay, so again, this is going to be a negative angle. This is π/4. This is 3π/4. Or these are negative, by the way. This would be -5π/4. And then this one up here would be -7π/4. And the way I always remember this for the ones that are over 4 is you're just counting up. You're just counting by odd numbers. You're going 1, 3, 5, 7. And so we have a clockwise turn of -7π/4. Fun fact, this is just going to be a reference angle of π/4. And this is the situation where both sine and cosine happen to be equal to the same number, which is √2/2. And then furthermore, we turned 3/4 of the way around, or maybe not quite 3/4. We turned most of the way around and we ended up all the way back in the first quadrant. So the sine and cosine values are now both going to be positive again. So if we're going to write the 6 trig functions, the sine of t, we're calling this angle t. The sine of t is going to be √2/2. Let's see, the cosine of t is also going to be √2/2. The tangent, if you do sine divided by cosine and they're exactly the same, you're just going to end up with the number 1. Meanwhile, if you do the reciprocal 2/√2, it's going to be the same for both of them if you rationalize it. That's 2 root 2 all over 2. And fun fact, 2 divides with 2 and they cancel out. So that means that the sine of t, or not the sine, sorry, the cosecant of t, that's what I'm after, the reciprocal of sine, that's going to be square root of 2. And then secant is actually going to be the exact same thing, since sine and cosine were both identical. Secant and cosecant are also going to be identical. And fun fact, the reciprocal of 1 is still the number 1. So there you have it. That is what we end up with for negative 7 pi over 4. Okay. My goodness, this is a long section. All right, what else do we have going on here? Okay, so next we're going to talk about even and odd functions. And so basically an even function is reciprocal across the y-axis. So an even function that has symmetry across the y-axis. And so the most basic example of an even function, which also shows you where it gets its name, the graph of y equals x squared, which is a parabola, it is a perfect mirror image of itself across the y-axis. If you flip it over, it is the exact mirror image of itself. And it turns out, we'll see this in more detail when we do the graphing section, but it turns out that cosine is also an even function, because it turns out that if you do the cosine of a negative angle, you end up with the same value no matter what. Meanwhile, what an odd function is, that has spin symmetry of 180 degrees. So the most basic example of an odd function is y equals x to the third. You'll notice it has an odd exponent. Let's try to draw that a little better. So anyway, what you have there is you have a curve, and if you were to hold it fixed at the origin point, 0, 0, and if you spun that 180 degrees, it would look exactly the same because of the S-curve shape of the graph there. So if you spin it 180 degrees, it'll end up looking exactly the same. Algebraically, here's what that means. If you put a negative sign in for the angle, for an even function, it basically has no impact whatsoever. So if I do cosine of negative 30 degrees, it's going to be the same as cosine of positive 30 degrees. The negative sign will have really no effect at all. For sine, as well as tangent, both of them are odd functions. And so what that would mean, and maybe it would be helpful if I were to write these things down, but like, so cosine of negative 30 degrees is equivalent to cosine of 30 degrees. Meanwhile, for tangent and sine, if you put a negative angle in, sine of negative 30 degrees turns out to be equivalent to negative sine of 30 degrees. So basically, if the negative sign is inside with the angle, you can pull it out to the front and negate the whole function. And then tangent ends up behaving the exact same way. So that's how even and odd functions behave. And this is just another way to help you approach figuring out the different trig functions for different kinds of angles. If you know the basic values for like pi over 3, pi over 4, and pi over 6, you can then use different algebraic tricks to figure out what it would be for any other kind of angle that they would give you, including negative angles. So they say if the secant of angle T is 2, then what is the secant of negative T? Fun fact, cosine and its reciprocal secant are even. So what that means, this is telling me secant of T equals 2. They want to know what would secant of negative T equal. Well, fun fact, because of the definition, if they are even, that just means that the negative sign will make no difference whatsoever. It'll still equal the exact same value. So the answer to this question would be 2, because negating the angle for an even function doesn't do anything. They say a cotangent of angle T is √3. What is the cotangent of -3? Okay, so sine, cotangent, tangent, and cosecant. That was kind of an odd order to list them in, but whatever. Anyway, these are our odd functions. So basically what they're saying is this is cotangent of T. They're telling us that equals √3. So the question is, what is the cotangent of -T going to equal? That's what they want to know. Well, fun fact, because it's odd, that means cotangent of -T is equivalent to the negative cotangent of T. So then what this will equal is just the negative of whatever we have before. So -√3 is what that in fact would be equal to, because the negation of the angle results in the negation of the entire result. Okay, here are some alternative definitions, and I kind of mentioned these earlier, but here they are again, introduced officially. So the definition of tangent is sine divided by cosine. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. Cotangent you can think of in one of two ways, either the reciprocal of tangent, or if you go back to the definition of tangent, what that means is cosine divided by sine. So here they say, given sine of 45 is √2/2 and cosine of 45 degrees is also √2/2, evaluate tangent of 45. So we've already kind of done things almost exactly like this here. So tangent of 45 is just going to be sine 45 over cosine 45. And then fun fact, they went ahead and told us what those are equal to. So that's convenient. We don't have to figure them out ourselves. This one's √2/2. That one's √2/2. Fun fact, if you divide anything by itself, doesn't matter how complicated it is, the answer is 1. Anything divided by itself will be 1. I guess the only exception to that would be 0, because 0 divided by 0 is undefined. But other than that, any like normal number. Let's see here. So here they say, given sine of 5π/6 is 1/2, cosine of 5π/6 is -√3/2. Evaluate the secant. Okay, so the secant. So we actually have extra information because we could care less what the value of sine equals for this, because really all we need is we need to do the reciprocal of cosine. And then again, this is going to be very similar to what we've already done. So we're going to do -2/√3. Let's try that again. Okay, that's a little better. So we basically care about this one for the secant. Rationalize your denominator here. And then that is -2√3/3. Again, please don't by accident go too fast and do the reciprocal of sine. The reciprocal of sine is the cosecant. It is not the secant. I make a big deal about that every semester to students, and yet there's always somebody who mixes that up. Consider yourselves warned. The reciprocal of sine is not secant. It is cosecant. Okay. Evaluate the cosecant of 7 pi over 6. Okay, so this should be reasonably straightforward. So where is 7 pi over 6 going to be? Well, pi is right here. That's equivalent to 6 pi over 6, which means 7 pi over 6 is just a little bit farther past that. So 7 pi over 6 is going to be right here. The reference angle is pi over 6. It's just going to match the exact same denominator. And as I've mentioned previously, that's a 30-degree angle. So across from that is a half. We are in negative y territory, which means we need -1/2. And then meanwhile, just for good measure, if this one's 1/2, the other one by default is going to be -√3/2. It's negative because we're in negative x territory. So the sine of 7 pi over 6, that's the y value, which is -1/2 right here. So if you do the reciprocal of that, the cosecant of 7 pi over 6, what that means is that's just going to be the reciprocal of that, which will be -2. So there you have it. So once you can get the basic unit circle value, finding the cosecant is just going to be the reciprocal of the value of sine for whatever you found. All right, here we're going to simplify trig expressions based off of the identities. So here they tell us we have the statement secant t divided by tangent t, and our goal is to simplify that using trig functions. The general strategy that we're going to use is we're going to try to get everything in terms of sine and cosine. Because those are the two foundational trig functions that define everything else. And then one other thing I'm going to do this first before I launch into this problem. Secant over tangent is another way of saying secant t divided by tangent t. That's just a slightly different way of writing the exact same thing. Now, what is the definition of secant? Well, secant is 1 over cosine of t. The definition of tangent is sine of t divided by cosine of t. Now, from here, we talked about this earlier. If you're dividing fractions, what you're supposed to do is change it to a multiply problem of the reciprocal. So we're going to multiply, and we're going to change this around and make this cosine t over sine t. And then when we do this, what happens? The cosines end up canceling each other out because you have one on top and one on bottom. So then after the chips have fallen, what we end up with is 1 over sine of t. And then we're not quite done yet because we have a definition for what sine of 1 over sine of t is equivalent to. That is in fact equivalent to the cosecant of t. So it turns out that the simplified version of that statement is that it's actually equivalent to the cosecant of t. Here's another one. Simplify tangent t times cosine of t. So we're going to use a similar sort of approach. We're going to replace tangent with sine over cosine. And then that is going to be multiplied by the cosine of t. Lo and behold, the cosine of t will end up canceling out in both situations. So when all is said and done, what is left is just the sine of t. That would be an equivalent expression to what they gave us. Okay, let's see what else is going on. These are alternative forms of the Pythagorean identity. So let's go back for a second and remind ourselves just what the Pythagorean identity is. Sine squared t plus cosine squared t is equal to 1. Now, I'm going to be honest with you, when I was a trig student back in the day and I had to memorize a lot of these formulas, in this instance, what I personally did was I just memorized one formula, the basic formula, sine squared plus cosine squared equals 1. And then I knew the little trick to transform these into the other formulas, because here's where these formulas are coming from. So if you take the basic formula, sine squared t plus cosine squared t equals 1. One way you could simplify that is you could divide everything by sine squared t. And if you do it everywhere to each expression, you will have an equivalent formula. And if you do that, what ends up happening? Well, sine squared divided by sine squared turns out to just be equal to 1. Meanwhile, we know from the definition, cosine over sine is the definition of the cotangent. So this is cotangent squared of t. And then 1 over sine squared, well, the reciprocal of sine is cosecant squared of t. So that's where this formula is coming from. So it's coming from dividing each of the parts of the original formula by sine. Meanwhile, if you again start with the basic formula, last time I divided everything by sine. Suppose instead I divide everything by cosine. Let's see what happens there. Spoiler alert, it's going to be the other formula that's written on this slide. Sine divided by cosine, that's tangent, yes. Sine over cosine is tangent. Cosine divided by itself is going to be 1. And then this is the reciprocal of cosine, which is secant. So this is secant squared t. And then that also goes to explain, they do it a little differently than I do. They actually start with cosine in their formula for the original one. But anyway, that's also part of why they have the ones sort of juxtaposed in different positions, because it has to do with how you divide. This, by the way, also explains, like, this is actually why cosecant is defined the way it is, because this has to do with the history of math, and like the Pythagorean theorem and the Pythagorean identity predates a lot of the other algebraic stuff. And so the reason why sine's reciprocal is defined as the cosecant is actually a consequence of how this formula works, because you notice in this formula, the cosecant and the cotangent go together. And then likewise, the secant and the tangent go together. They're in the same formula. They're on opposite sides of the equal sign, but that's partly why the secant and cosecant are defined the way they are. It has to do with these formulas to make them nice and pretty. But anyway, there you have it. Those are just two alternate versions of the Pythagorean identity. So they say if cosine t equals 12 over 13 and t is in quadrant 4, find the values of the other trig functions. All right, I'm going to show you a little trick that will maybe make your life a little easier. So they're telling us that this is 12 over 13. And what we can do is just say, okay, I'm down here in quadrant 4. This is the cosine And if we go back to SOHCAHTOA, cosine of the angle T is the adjacent over the hypotenuse. So if it equals 12 over 13, what that means basically is that the adjacent side is going to be 12, and then the hypotenuse is going to be 13. And if you do it that way, you can make your life a little bit easier and just use the normal Pythagorean theorem. Call this one A, we'll call this one B, and then that will be C, the hypotenuse. And you can just use the Pythagorean theorem to find the missing side that you don't know. So that's 12 squared plus B squared equals 13 squared. That's giving me 144 plus B squared equals 169. If you subtract, B squared is 25, and then B will be plus or minus 5 when you take the square root. Fun fact, I am in negative territory for the y's. So this is going to be equal to -5 for that side right there. So now that I have all three sides of this triangle, I can then write the trig ratios for each of the different functions. So sine is going to be the opposite over the hypotenuse. That means sine of t is going to be -5 over 13. They already told me cosine of t, that is 12 over 13. For tangent of t, tangent is the opposite over the adjacent. That just comes from SOHCAHTOA again, the definition. So if we do the opposite over the adjacent, we get -5/12. And then once you have those, you can just flip them all upside down. And you can then obtain the other trig functions. So the cosecant is going to be -13/5. The secant is going to be 13 over 12. And finally, the cotangent is going to be -12 over 5. And there you have it. When all is said and done, those are the 6 trig functions for that trig ratio in that quadrant. And like I said earlier, just remember that because we are in quadrant number 4, cosine is positive, sine and tangent are both going to be negative in quadrant 4. And lo and behold, based on the answers I got, that bears out that that's what was supposed to happen. So there you have it. If secant t is -17 over 8, and then t is between 0 and pi, find the values for the other 5 functions. Okay, well, I can tell you right away that cosine of t is just the reciprocal of that, which makes it 8 over 17. So that one is pretty easy. We can find that without a whole lot of trouble. Let's draw ourselves a sketch here. So it's between 0 and pi. And the thing to notice is that cosine is negative. Now, if I am limited to just these 2 quadrants, the question is, which one would have a negative value of cosine? Well, the answer is we know that all trig functions are positive here. Only sine is positive here in quadrant number 2. This is where sine is positive, cosine is negative, and then tangent would also be negative. So we know that we are going to be in quadrant 2 over here. So then what we need to do is we need to figure out what is the missing side. And again, Pythagorean theorem can come to our rescue. So this is going to be -8 for the adjacent side. The hypotenuse is going to be 17. And if we call this one A, call that one B, this one's going to be C. We can use Pythagorean theorem again. -8 squared plus B squared equals 17 squared. I won't go through all the details of this, but I would suggest you just try it yourself and verify this. But what it's going to be is the number 15. That also happens to be a Pythagorean triple, 8, 15, 17, if you happen to know Pythagorean triples. But anyway, 15 is going to be the value of the missing side. So here's what we can do. So we're going to do sine, we're going to do cosine, we're going to do tangent, and we're going to do cosecant, we're going to do secant, and we're going to do cotangent. And we're going to write them all over here, nice and neat, all 6, all nice and tidy in a row. So sine is going to be 15 over 17. Cosine, we figured out earlier, that's -8 over 17. And then they actually told us secant from the very beginning. If you flip this over, cosecant will be 17 over 15. The tangent is going to be the opposite over the adjacent, which makes it 15 over -8. Fun fact, that's really just the ratio of the denominators of sine and cosine. And you kind of ignore the hypotenuse of 17 altogether. Once you know this, flip it upside down, -8 over 15. And there you have it. There are the 6 trig functions based off of the information that they gave us. Let's see here. So then there's the period of the function. And so this basically just says how often, how long of a cycle does it take for the function to repeat itself? And so basically the idea is this. For my unit circle here, if I have this angle at pi over 4, if I then do a larger angle where I spin around once and then go back to the same position, that's going to be pi over 4 plus 2 pi, which is going to end up being 9 pi over 4 if you were to work that out. And so basically, sine and cosine repeat themselves, and by extension, secant and cosecant do the same thing. They repeat themselves every 2 pi because you've just gone one complete lap around the circle, and then anything you do beyond that is just going to take you back to a position that's the same as a lot of the other ones. Cotangent and tangent are actually special because they have a period of pi, because it turns out if we do pi over 4, that has a tangent of 1. If you add pi to that, which is another 180-degree turn, if you add pi to that, that's going to put you down here at 5 pi, or 5 pi over 4 is what this is. And fun fact, this is also going to give you a tangent of -1, because even though this is negative and that's negative, when you do the ratio, you still end up with a positive tangent. So the period of most of the trig functions is 2 pi. That's how often it repeats itself. Tangent and cotangent are the special ones because they actually repeat every cycle of pi. And let's see, what else is there here? Okay, I do want to press on and finish. I know we've gone over an hour here, but my plan for tonight is to only do this section. So once we finish, we'll just be done. So I want to press on and just try to get this complete, and then we're going to call it an early night whenever we finish this here, just so you know. All right, so find the values of the 6 trig functions based on that figure. So this is pretty similar to stuff that we did before. There's your x value, there's your y value. So sine of t is going to be -√3/2. Cosine of t is going to be -1/2. If you do the ratio of those, tangent of t will just end up being +√3. And I'm not going to go through all the details of this, but because I've done them all before, but like if you do cosecant, that will give you -2√3/3. If you do secant, you're going to end up with -2. And if you do cotangent, that's going to give you √3/3. So I'm not going to go through every last detail with this because we've done several examples like this, but those would be the 6 trig values based off of that point. Okay, let's see, find the values for this. So here we have 0 and -1. So again, the x value is cosine, the y value is sine. So cosine of t, that will be 0. Sine of t is going to be -1. If you do the reciprocal of 0, that's undefined. If you do the reciprocal of -1, it is still -1. For tangent, if you do sine over cosine, -1/0, that's going to be undefined. So tangent is going to be undefined. And then if you do the cotangent, you do cosine over sine, which is 0/-1, also known as 0. So those are the 6 trig values for that one, that point. Let's see here. This is kind of more of the same. So let's see here. So sine of t, we already know. The cosecant is going to be the reciprocal of that, which is -2√3/3. The cosine is 1/2. The secant is 2. The tangent, if you do -√3/1, you just get -√3 for the tangent. Cotangent is going to be -√3/3. That will be the 6 trig values of those. All right, then this is very similar. So what do we have? So we already know sine. That's √2/2. If you do the reciprocal of that, you're going to get just √2. For cosine, it is also √2/2. The secant of that, the reciprocal of that is √2. Tangent, these are both the same. So sine divided by cosine is 1. And fun fact, the reciprocal of 1 is still 1. So that is the cotangent. Lastly, they say how to do this in a graphing calculator. So fun fact, calculators don't typically come with secant, cosecant, and cotangent values. So if you are trying to use those in a calculator, what you basically have to type in is something like the following. So if you want cosecant of 5 pi over 7, what you would need to type is this. You would say 1 divided by sine, and then in parentheses, 5 pi over 7. And then if you do that, let me grab my calculator here. So if I do 1 divided by sine, 5 pi divided by 7, and let me actually write it the way it would look on the calculator. So that would be 5 pi divided by 7. And if you do that, see, they don't tell us how many decimals to give them. I'll just give them 3. 1.279 is approximately how much that is equal to. So if you were using a calculator to evaluate these, you'd have to do 1 divided by sine. One thing I want to note, cosecant of t is not the same as sine -1 of t. Sine -1 of t is the inverse sine. It's also sometimes called the arc sine, which means something different than doing the reciprocal. And with powers, if you raise it to the -1 power, yes, that does give you the reciprocal, but that's not what sine -1t means. And that's partly why the arc sine notation exists, to try to avoid that confusion, but people still use sine -1 anyway. But anyway, well, hardly anyone uses cosecant in the first place. So, but anyway, just be aware those are not the same thing. We've got one example left. So if you're going to do the cotangent of -pi/8, how you would type that in, you do 1 divided by tangent, and then in parentheses, -pi, come on, -pi divided by 8. And if we do that, 1 divided by tangent of -pi divided by 8, that's going to end up giving you -2.414. Okay, so there you have it. That is the end of section 3.